All right then, welcome back everyone. So in this video, we are going to solve this question, Pascal string. Now this is also one of the famous interview questions, and for some reason, Amazon loves this question very much. So this question has many variations. So this question has many variations. There are three variations basically, but they all revolve around this idea of Pascal's triangle. We all have studied what is Pascal's triangle of plus two. This is how Pascal's triangle looks. So basically, to get a particular entry, you just sum the basically sum two values of the previous row, right? To get this three, basically sum the two values of its one to above. This is how you calculate a particular entry. Now, basically, the first variation, I told there are three variations, right? So the first variation of this question revolves around finding a particular entry. The second variation involves around finding a particular row. Okay, so you can be let's say either ask what is this value or the entire row, or what LeetCode asks, you have to return the first number rows. So basically, they are asking how many rows needs to be returned. Okay, so here's how I'm going to approach the question. So I'm going to build up the idea of Pascal's triangle, what mathematical concept is required, and then we can solve all three questions. All three are very easy questions, nothing much. So for starters, there's one thing I want to do. So they are making the rows one index. Okay, they're asking for let's suppose five rows or six rows. I'll keep things simple because as we are familiar using arrays, we are familiar with zero-based indexing. I'll index the rows from zero only. Okay, so nothing changes frankly. What LeetCode is asking is they are asking first n rows. Okay, so what you can do is you can just reduce this n to n minus 1 and use the logic whatever. Now, okay, let's solve the first variation. Okay, the first variation of this question. Find me a particular entry of Pascal's triangle. Find me this value. So it actually, the proof directly comes from binomial theorem, and which is a bit out of scope of this video. So if you are given a Pascal's triangle, as I've already taken a zero index Pascal's triangle, and if you want to find out some entry, let's say I want to find out fifth row's second entry, columns are also zero index. Okay, this is zero, first, two. Okay, or entry, column or entry. I'm just calling it entry. Okay. So if you want to calculate this value, fifth row's second column's value, you can just plug it into this. This is basically a combination. Okay. Some people write like this also. So basically, if you want to find out, if you want to find out PRC, basically rth row's cth entry. Okay. Or basically in a triangle, the value of this set, RC. Okay. It's basically R choose C. Let's see how we can calculate this R choose C because all the three variations revolve around this factor. Okay. So we are dealing with the first variant. We want to find out a particular element in the Pascal's triangle. Okay, so this is basically just asking me what is the optimal way to calculate this R choose C. If you know the formula of this R choose C, uh, so let's just discuss the general problem. I want to calculate n choose k. So what is its formula? N choose k can be written as n factorial upon n minus k factorial into k factorial, right? So this is the formula of n choose k. Now, one method is to just calculate this factorials individually. Okay, calculate this factorials individually. Calculate this, right? It actually consumes a lot of time, right? It consumes the order of n and order of n minus k and order of k. So this actually consumes all in all order of 2 and I don't want this. I'm not interested in the solution. Uh, how can I calculate this optimally? So let's see. Let's try to make some observation by some examples. Okay. So here's how you calculate 5 choose 3 in a plus 2, right? So what you used to do is you're gonna write like 5 into 4 into 3 and then 1 into 2 into 3, right? So here's how you calculate 10 choose 5. So you don't usually use this formula, this 10 factorial upon 5 factorial into 5 factorial. Usually don't use this formula. This is 3 and then divide by 1, 2, 3. So this is how we calculate combinations. Now, is there an observation here? Is there an observation here? See here. So basically, I can write this like 5 by 1 into 4 by 2 into 3 by 3. Okay, this is how I can write it. Okay. So if you see, this 5 becomes 4, 4 becomes 3, this 1 becomes 2, this 2 becomes 3, right? So this is decrementing by 1, this is incrementing by 1, this is incrementing by 1, right? So that gives me a hint. That gives me a hint I can exploit it. So what is this basically? This is n, right? This is n. So basically, what is this? This is my n. And what is this? This is my k, right? So basically, can I write a simple for loop? Can I write a simple for loop? And in the first iteration, I can calculate this. In the second iteration, I can decrement, I can decrement this guy and I can increment the denominator, right? When I do is, I can like start from, let's say, I equals to 0, I equals to 0, I equals to 0 till k, basically not including k. In the first iteration, what I can calculate is, let's say I can initialize my result to some fun. The first iteration, I know results needs to be multiplied with 5 by 1. What is this 5 by 1? This 5 by 1 is basically n, okay, n minus I, 5 minus 0 upon I plus 1, right? Because for I equals to 0, this is actually equal to, I want to, this is equal to 5 by 1, right? I equals 0, this should be equal to 5 by 1. Okay. Then for I equals to 1, I equals to 1, this would be equal to, for I equals to 1, this would be equal to n minus 1 upon 1 plus 1, 4 by 2, right? So for the first iteration, I'll get 5 by 1. Then I'm going to multiply in the second iteration with 4 by 2. This is incremented, this is decremented. In the third iteration, I'm going to multiply with 3 by 3. This is incremented, this is decremented. Sorry, this is incremented and this is decremented. Fine. So I can write a simple for loop. So that's what I'm going to do. So basically, I'm initializing with, I mean, the result with long because this multiplication might cause an overflow. So that's the reason. So result is 1. Okay. The first guy is this, see this, the first guy is 10 by 1. So it is basically 10 minus 0. Okay. Upon I plus 1. Then 9 by 2. 10 minus 1, 1 plus 1. Then I have to multiply to 8 by 3. 10 minus 2, 10 minus 2, 2 plus 1, 3. Okay. And the order matters here. So I was saying that the order here matters. You have to first like multiply by this 9 and then divide by 2. Okay. Now the reason is like let's say if you try to divide by 2 first, this is not going to yield correct result, right? If you like by 5 by 1, you cannot first divide it by 2. But first multiply it by 4, then you divide it. That's what I was saying. Okay, fine. So we are done with the first variant. Now the time complexity is simply order of 2 because we are just doing k iterations. So uh, this is the first variation done and dusted. Now let's move on to the second variation. We want to find out the nth row of Pascal's triangle. Again, I'm dealing with the zero-based indexing. So you asked me nth row, you mean if you mean fifth row, basically you're asking me this row. Okay. All right. The one simple way, I guess you have since you've learned this formula, you can calculate this nth row straight away, right? Now, but how are you going to do it? Let's see. There's one observation needed to be made here. The observation is this. See, if you have zeroth row, you have one entry. If you have first row, you have two entries. If you have second row, there are three entries. So if you have n row, basically nth row will have n plus one entries. Okay. So if they are giving you to find, give me the value of n, you need to first initialize the list or basically a vector wherever you want to store your answer, and put all ones in it, all ones or whatever. You need not put it, whatever you want to put it. Uh, I told you to put all ones because the first and last entries. But anyway, you can put anything you want, and then calculate all the values, right? So basically, if they are asking let's say fifth row, then you can calculate, then you can initialize a list of size 6, and then you can calculate the values from 5 choose 0 till 5 choose 5, right? These are 6 values. Entry number 0, entry number 1, 2, 3, 4, 5. Now, this is the brute force approach, but this is not a good approach. Why? Because it will consume a lot of time, right? It's obviously for nearly half of the entries, here already written the example. This is fifth entry, right? For nearly this half of the guys, they're going to take big of n by 2 time, right? Because as I'm saying, there are n plus 1 entries, and I know the loop runs for order of k times. The loop runs for order of k times. So, now for nearly half of the entries, you're going to consume order of n time. So, this is not good. Total time will be basically order of n square. Now, because each calculation, each n choose k is taking order of n. Right? So that's a better way. We can actually accumulate values in a single week of an iteration. Okay, you will not get this straight away, but let me write down. So here I have written the fifth row from above, so you can verify it afterwards. But this is the fifth row. So you know the values that you need to be calculated are 5 choose 0, 5 choose 1, 5 choose 2, 5 choose 3, 5 choose 4, and 5 choose 5, so on. Uh, for now, let's forget what these values are because they're anyway ones. So I can just initialize the list with ones and I'll put everyone as one. So what I'm interested in, how can I calculate these values basically from the first guy till the n minus fifth guy, right? So I want to calculate these n minus that was n plus one values, right? So basically this portion, right? This total is n plus one, so two gone. So I want to calculate n minus one. How can I calculate this n minus one entries? Let's see. Let me write down what each of them mean. So this 5 choose 1 is basically 5 by 1, right? This 5 choose 2 is 5 by 1, 4 by 2. We already written it, right? We already discussed why this works, like how I'm writing this. It is 5 into 4 into 3, 1 into 2 into 3. There is something a pattern here. This is 5 into 4 into 3 into 2, and 1 into 2 into 3 into 4. So from the first entry, if I want to get the second entry, if I want to get the second entry, I can reduce this numerator by 1 and increase the denominator by 1 and just multiply it, right? So from the second entry, if you want to get the third entry, what you can do is you take this 4, decrement it, you take this 2, increment it, and just multiply. So the same logic that we use for calculating the R choose k value, we can use it, right? Because what are you doing is in the process of calculating n choose k, We are already calculating all the values for k equals to, let's say, 1, 2, 3, so on and so forth, right? So when you are calculating like 5 choose 4, if I already have a value of 5 choose 3, already have 5 choose 3, I can just multiply by 2 by 4. And my topic is done. That's exactly what I'm going to do. Okay. So that's exactly what I'm going to do. So I initialize temp with 1. See, I know there are n plus 1 elements, there are n plus 1 entries. So I'm going to first initialize my answer with n plus 1 entries and all are 1. Okay. And then I'm going to basically calculate the remaining entries. I'm not going to worry about these two guys. I'm not going to worry about these two guys. I'm only going to worry about these guys. So I'll go from 1 to C less than rows. Basically, I'm calculating n minus 1 entries, right? Because there are total n plus 1 entries. This is gone, plus 2. So basically, n minus 1. Okay, so where was I? I initialized the answer and then I initialize like basically this is 1, right? So you can say the first entry was 1. Now I'm going to start calculating from here. How am I going to do? I have to multiply it with 5 and then divide by 1. So I'm going to do like this. I want this first entry, okay, to multiply it with n minus 1 plus 1. So basically, uh, this was 5 minus 1 plus 1 and divided by c. This is what? 1, okay, and add it to the answer. And add it to the answer. Come to the next iteration. Come to the next iteration. Come to the next iteration. Now I already have stored 5 by 1 in my temp. So come to the next iteration. Now calculate, multiply it with 5 minus 2 plus 1. What is this? This is 4. This is 4. And divide it by 2. So basically, I'm going to multiply 5 by 1 with 4 by 2. Multiply 5 by 1, multiply 5 by 4 by 2. So this is how I basically incrementally calculate the values, right? So I mean, it's very obvious. I don't know if I'm able to explain the iterations well. So basically, uh, I'm just calculating these values. The loop I have written is basically it's also gonna calculate this value also. What is the time complexity here? The time complexity is simply order of n, right? Because we are just doing a uh, single loop of order of n plus 1, right? Not of order of n. We are only calculating dimensionality, so it's a order of n loop. So the complexity analysis is simply big O of n. We are not using any extra space. I mean, if you are counting the space used for output, yeah, then very well say that the extra space uh, used, we are using extra space. But if we are not counting the storage used for output, then it's simply a big O of function. Variation 3. Now we have to generate the entire Pascal's triangle. Now one approach is simple. The one approach is simple that we know that we want to generate n rows, right? So you can first basically use the above algorithm for generating a row and apply n times and add it to the answer, right? So you can basically make a list of lists or vector of vector, and you can make a for loop run from, let's say, row equals to 0 till n, right? Not including it, equals to, right, row till n. So you can run a for loop, let's say row equals to 0 till n, and you can use this thing. You can use this print instead of print. You can ask this to return, right? It's not returning it, so you're returning it. Fine. So it will return you the row, okay, and you can just append it down. So that's one way. It's order of n square approach, simple approach, and that's the best you can do because yeah. So that's the big of n square approach. Now there's one more approach to this. Now it is based on observation that we can compute the current row using the previous row. It's like it's simple. I guess they already made an observation. Like most of the guys uh, come up with this solution only when they first see this problem. See, if I want to calculate this row, what I'm gonna do is see. I know anyway. First and last entries are fixed. First and last entries are fixed. I'm not gonna do anything. But from so, if I write the triangle like this, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. Now it will make sense. If I want to calculate the 6, I have to take a value just above it and left diagonal, right? The upper left diagonal. Value just above it and upper left diagonal. That's what I can do, right? Cool. So yeah, that's how we can develop a constructive algorithm. So, let me just show you. It's a very simple one. It's a DP if you think about it because we are using that. We are remembering what was the previous row. So they call it the dynamic programming approach, but I feel like it's just a constructive algorithm. Anyone can figure that out. Right, so the solution is simple. See, this is the solution to the lead code question, basically what they've asked. So okay, I guess we have finally arrived to the lead code solution. Okay, so they're asking me to calculate, give me the first n rows, right? So it is as good as asking me return me 0 to n minus 1 rows from whatever we have discussed. So that's what I'm gonna approach. So of course the list will be of size n. It will be a vector of vectors. Okay, and then I'll run a loop. See, it goes from 0 to n minus 1, right? This loop goes from 0 to n minus 1. I know in ith row there are n plus 1 entries. So basically, I'm initializing the basically ith row of triangle to be of size I plus 1. That's what the resize does. Okay, and I need not worry about the first and the last entry, that is the zeroth entry and the basically if it's a fifth row, I need not worry about the zeroth entry and the fifth entry, right? So just confirm it. 1, 5, 10, 10, 5, 1. So this is 0, 1, 2, 3, 4, 5. Yeah. So we need not worry about these entries, 0 and 5. Okay. So we have to care about these values. So go from j equals to 1 to number called minus 1. So it will this part only. It will it will this part only. And what is this? Uh, Basically, this is left diagonal. This is left diagonal. This is left diagonal. This is just above, right? So to calculate a particular entry, go to one row above, take the value, take that value, and the value of top left diagonal. That's what this is. And this is left diagonal, and this is just above value. So this is how I can do. I can go for every column and calculate it. So yeah, that's it then. I'll summarize quickly what we have done. So basically, the question was asking us, there were three questions, but they all revolved in the concept of Pascal's triangle. The first question was asking, give me a particular entry. Now that question was basically simply boiled down to how can I calculate R choose K or N choose K effectively. That we figure out using some observation that it can be done in simply order of K time using the simple observation, right? So that's how we do it. And then to find the nth row, one way was to basically compute the nth row using the formula of n choose k, but that would consume a lot of time. So we didn't go that way. But otherwise, we found out okay, a simple observation, we can accumulate values. We can accumulate values, right? It was 5 into 5 by 1, then it was multiplied by 4 by 2, then multiplied by 3 by 3, so on and so forth. Basically, it extended upon the idea of how we calculate n choose k. And then we are asked to generate the entire Pascal's triangle. One way was to simply basically we know we want to calculate n rows, right? So one way is to basically go through all the rows and use the formula, right? We can generate a row, can basically go through every rows and use this function, print Pascal row, return Pascal row. I should have named it more good that this is return Pascal row and calculate n rows of the Pascal string. The second approach is basically simply based on observation that to get a particular value, in Pascal string, I need a one value just above it and the top left diagonal. To get a particular value, I need a value one above it and its top left diagonal. Okay, so to get a particular value, I need a value just above it and its left diagonal value. Okay, so that's what I did. That I'm necessary anyways order comes with and order one if you're not counting spaces. So yeah, that's it then. Thank you for watching. I hope you got something out of this video. I'll see you in the next video.